Okay, so this video is about expanding logarithms, and there's some properties of logarithms that we're going to kind of infuse into this as we kind of go about this. So you'll notice that numbers 5 and 6 have numbers there, so you could legitimately actually evaluate them if you wanted to, but we're not going to evaluate. All we're going to do is expand. So you don't have to worry about actually getting a decimal or numeric answer. So we're just going to expand them and then go from there. All right, so for number 5, it's log of 2 to the 4th divided by 5. All right, so one of the properties of logarithms is if you divide, you can actually separate this problem into 2 separate logarithms and you subtract them from each other. So I can write log 2 to the 4th minus log 5. Because notice how 2 has an exponent of 4, 5 doesn't, so there we go. And then one of the other properties of logarithms is with exponents. If I have an exponent on a logarithm, you actually move it to the front of the logarithm because basically in an exponent, because logarithms are about solving exponents. So it's whatever answer you get, you just multiply it 4 times is basically what we're saying. So it's going to be 4 log 2 minus log 5. Okay, so the 2 properties, again, that we demonstrated is when you divide with logarithms, you can separate them into 2 separate ones and subtract them from each other. Also, when you have an exponent, you move the exponent of the logarithm to the front of the logarithm and just multiply it at the end. Okay, so for number 6, notice how it applies to both the 6 and the 5. So actually my first step here is I'm going to move the 6 in front of the logarithm. So it's 6 log to the 6/5 power, 6/5. And then if I'm dividing, again, I'm going to separate them into 2 logarithms and subtract. So it's going to be 6 log 6 minus 6 log 5. Because the 6, the exponent that we moved earlier, applies to both logarithms. So we have to make sure they apply to both. All right, number 7. All right, so I'm dividing again, so I'm going to separate and make it 2. So log x minus log y to the 6th. But notice how it has an exponent that I need to move to the front here. So it's going to be log x minus 6 log y. Number 8, because it has an exponent and it applies to both numbers, so let's move it up to the front. So it'd be 2 log a times b. And then we split that up to be 2 log a plus 2 log b. So I guess another way you can kind of think about it, like usually when I'm dealing with exponents, I distribute the exponent to both numbers. So let's go back to number 6, for example. Like I can apply the 6 both here and have log 6 to the 6 over 5 to the 6th. Right? And then I could separate it out like that, and you get the same thing, but that's another way to think about it. All right, number 9. So for number 9, so I have log u to the 4th minus log v, because I'm dividing, I subtract. And we move the 4 up in front, so it'd be 4 log u minus log v. All right, number 10, just like number 9, but now notice the exponents down on the bottom. That's okay. So log x minus log y to the 5th. We move the 5th power to the front, so I'd have log x minus 5 log y. Okay, so that's just kind of the basics of the properties of logarithms. So mainly dealing with if I'm multiplying, I add 2 logarithms. If I'm dividing in the one single logarithm, I can separate them and subtract 2 logarithms. And whenever I have an exponent, it could be applied to the front of the logarithm. So that's kind of the basic properties of how to expand logarithms.